All right, so we're gonna be drawing the stick structure for this chemical right here at the very top, CH3, CH2, CH3. Now we learned how to take a look at these formulas in the previous unit. We said that if the elements are split up like this, then we have to just kind of assume that they are together. So we got this CH3 together, this CH2 together, and then this CH3 are together. Okay, so when the elements are split up in the formula like this, we assume that they are together. So I'm gonna color code them so that you guys can kind of see it a little bit better, but you guys don't need to color code it. So this red CH3 are going to be together. So we know carbon's always in the middle and hydrogen is on the outside. So we're going to just kind of structure it like this. Okay, that's this red part right here. And then we got the blue CH2. We're going to put the C in the middle and then the hydrogens around it. And then on the far right, we got the black section. We got C in the middle and then H surrounding it. Okay. So when the formula is split up like this, we learned that it kind of tells us how the elements are grouped together. And then what we're going to do is we're just going to connect everybody together, and this is going to be your structure for this molecule. Okay. So this should be pretty much a review. Any questions on this part? Not too bad, right? Okay, now this is kind of a big structure, right? And we got 3 carbons. Okay. However, as we go towards final and the research that you're going to do on your final, you're going to have molecules that are a lot bigger than this one. Things like C17, H35, like O2. So like really big molecules. And this is how big a molecule with 3 carbons is. So you guys can kind of imagine how annoying it must be to draw something that has 17 carbons, right? So we need a way to draw these structures, but a lot easier for you guys to draw. And that's what we're going to learn how to do today. We're going to learn how to draw something called a skeletal structure. Okay, the stuff we've been learning is the stick structure. We're going to learn the skeletal structure now. Okay, and the skeletal structure is super easy to draw. Okay, there's only 2 rules that you guys really need to know for it. Okay, the first rule is that we are going to replace every single carbon with corners. Okay, so you might want to jot that down somewhere. But every single carbon is going to become a corner. And I'll show you guys what that means in just a second. Okay, but we're going to replace all the carbons with corners. Okay, and the second rule is that if there's an H that's connected to a carbon, we don't draw it. So all of these H's, you see how they're all connected to a carbon, right? We're not going to draw them anymore. So you can already see how it's going to get a lot easier to draw. Okay, however, if H is connected to another atom, you still need to draw it. So for example, if it's connected to like an N, right, a nitrogen, you still have to draw it. If it's connected to an oxygen, you still got to draw it. Anything other than a carbon, you got to draw those H's. But any H connected to a carbon, you don't need to draw. Yeah, this is going to be the big question on your final. Most of your final is super easy. It's just research. But there is one question that's worth 25% of the final. You're gonna need to know how to do this. Yeah. All right, so let's take this stick structure right here and let's draw the skeletal structure. Yeah, what's up?
Sorry. It says replace C with all corners. Is that just for C or that apply for any molecule?
Just for C. Yeah, and I'll show you what it looks like in a second. It's a lot more complicated here than when we actually do the problem. So before we start, let's take a look at our stick structure and let's count how many carbons there are. Okay, I'm gonna put numbers next to them just so we can see it a little bit better. But let's say this guy is carbon number 1, this guy is carbon number 2, and this guy is carbon number 3. Okay, so 1, 2, 3 carbons. So when we take the stick structure and make it a skeletal structure, we just replace all the carbons with corners. So let's take carbon number 1. We're going to make it one corner of a line, and it's going to connect to carbon number 2. So carbon 1 is right here. Carbon 2 is right here. And then we could turn carbon 2 into a corner to connect it to carbon 3, and there you go. This is the skeletal structure of this molecule right here. Super easy. And you could probably see why we would want to draw it like this, right? Because we don't need to draw the carbons, but it still communicates to us all the information that we got. Just redoing it? Yeah, no worries. Okay, so we numbered the carbons. There are 1, 2, 3 carbons, right? And so we got to turn all the carbons into corners. So I labeled them with the 3 numbers. And so if we want to draw a picture of it in the skeletal form, we just turn these into corners. So carbon number 1 is going to be this corner right here, this red corner. Carbon number 2 is going to be this blue corner, right? The blue one. And then the black corner is going to be carbon number 3. So all we're doing is making a line. You could do it either this way or this way. Doesn't matter. Yeah.
Are we when we're doing this types of questions, do we have to label it with C or do we have to do it with numbers?
You don't need to do C or the numbers. You can literally just, I just did it so it's easier for you to see, but if you put this will be the correct answer right there. Or this will work too. Okay. So I know this one might be a little bit weirder because it's such a small molecule, but you'll see why this is helpful as we do the next 2 examples because we'll have bigger molecules, okay? All right, ready to move on? Okay, let's look at a molecule that's a bit bigger and uglier. Okay, so please don't draw this. It'll be up there on Canvas for you if you guys ever want to take a look back at it. But even this, right, there's only 4 carbons, but it's already super big and kind of annoying to draw. So we're going to take this and turn it into the skeletal structure. So what I'm going to do is I'm going to start by just numbering the carbons, just so it's easy for us to look at, okay? So this is carbon 1, this is carbon 2, we got carbon 3, and carbon 4, okay? So let's get started. So carbon number 1, it only has hydrogens on it, so we can kind of ignore the hydrogens and we can create this corner, and this will represent carbon number 1. Carbon number 2 also only has hydrogen, so we can ignore all those guys, and so this is carbon number 2. So just by drawing this line, we have done this half of the molecule. Okay, let's go to carbon number 3 now. So we're going to go to carbon number 3. Okay, so if you guys take a look at carbon number 3, it has a double bond with an oxygen, right? So what we're going to do is we're just going to do a double bond with an oxygen on carbon number 3. Now, it doesn't matter if it points upwards or downwards. What matters is the connection. So you can do it like this. Okay. And then lastly, we go to carbon number 4. So we draw a line to make carbon number 4. And if you take a look at carbon number 4, it has a triple bond with a nitrogen, right? So we're just going to triple bond it to a nitrogen. And this nitrogen is connected to 2 hydrogens. And so we got to draw them because we only ignore hydrogens connected to carbon. So there you go. This is the skeletal form of this guy right here. It's a lot easier, right, than to draw all of the carbons and things like that. Yeah.
Sorry for asking.
No, you're showing.
But when we're doing the skeletal structure, we're following that little zigzag.
Yeah.
So we keep doing the zigzag unless it's a double bond. We do a double bond. We continue the zigzag.
Exactly. Exactly. And it doesn't matter which direction you go. So if you notice, I went up first. It's okay if you go down as well. So this right here, I'll do another example, will be just as fine for your answer. So like this. This would be fine as well. Okay, all I'm doing is flipping it, right? It's the same thing. So the direction doesn't matter as long as you got the same connection. Okay. Guys think you could try one on your own? Okay, so the next one I'm going to show you, it might look a little overwhelming, but just count the carbons, and that's probably the easiest way to do it. Okay, so let's go on to the last example, and I'll have you guys start your assignment. Okay, so yeah, it looks weird, it looks overwhelming, but just count the carbons and try to connect everything together based on which carbon number it is. Okay, so I'll give you guys about 3 minutes to do this. You can work with the person next to you. Again, start by counting the carbons and then adding on things after. Just the skeletal structure. Okay? If you want to copy this down because it might be easier, then you can, but not required. So when we want to turn this into skeletal structure, again, the easiest thing in my opinion is to count the carbons. So I'm going to count the carbons. So in the middle, you guys are going to notice there are 1, 2, 3, 4, 5, 6 carbons, right? That's probably the easiest place to start, where it makes that shape in the middle. So all we're going to do is make that shape. Oops, I can't draw a straight line. So like that, like that, like that, like that, like that, and like that.
It's Stewie's head.
Okay, so we got a hexagon, right? 6-sided shape. So we got 1, 2, 3, 4, 5, 6 carbons. And so we just got to make sure there are 6 corners on our shape in the middle. So 1, 2, 3, 4, 5, 6. Make sense?
No, look what I did. Look what I did.
Okay, because we got this closed shape right here. Now, if you guys take a look at the shape, there's some double bonds in there, right? So there's a double bond from carbon 1 to 2. So we'll make a double bond from carbon 1 to 2. There's a double bond from 3 to 4. So we'll put a double bond on 3 to 4. And from 5 to 6. So we'll put it on 5 to 6. Okay? Don't stress too much if you didn't get this. It's a new concept. We have some time until the final to prep for it, okay? All right, so far so good, guys? Okay, for sure. Thank you. Thank you, student. Okay, so if we look at carbon 1, the only thing connected to it is a hydrogen, right? But since the hydrogen is connected to a carbon, we can ignore this guy right here. So we can ignore him. Carbon number 2, there's only a hydrogen, so we can ignore that. Okay, which takes us to carbon number 3. Now, carbon number 3 is connected to another carbon. So what we're going to do is we're going to draw a line to make another corner. I'm going to call this carbon number 7. Okay, it doesn't really matter how you number them, but let's call this carbon 7. And carbon 7 has a double bond to an oxygen, so we'll double bond it to an oxygen. Okay? And since there's a hydrogen, we can ignore that one. Okay, we look at carbon number 4. It's a hydrogen, so we can ignore that. Carbon number 5 is connected to an oxygen, so we're going to connect it to an oxygen right here. And that oxygen is connected to another carbon. I'll call that carbon 8. And so we'll draw a line, and this will be carbon 8. Okay, so again, just count the carbons. That's the easiest way to do this. And then lastly, we get to carbon number 6, which is connected to an oxygen. So oxygen. And this oxygen is connected to a hydrogen, so we just draw that, and there you go. This is the structure for this guy right here. Okay, and you don't need to write the numbers in your final answer. I just put the numbers there so you guys can kind of compare it to the stick structure on the top. But basically, do the same thing without the numbers. Alrighty, guys. Well, anyway, I'll give you the rest of the class period to work on this assignment. Let me know if you guys have any questions. I know it's still new, so don't freak out too much. It's gonna be a little bit difficult, but I'm here to help you out, and I got the answer key if you guys want to check. Okay. So good luck, guys.